So you wish to determine the uncertainty in your gradient, given a set of data where each point contains uncertainty. So when we look at gradient is equivalent to the slope. When you look at the slope of a linear function, gradient represents the same exact thing. So we calculate it the same exact way. So I took the furthest left, furthest right coordinate and calculated just that, the gradient, and got a value here of negative 0.499. So that is what we would say is our true value. So then we need to determine the uncertainty in that. So I'm going to utilize this as my formula and taking the uncertainty in the y values and the uncertainty in the x values and going through our error propagation. So in looking at this, we have y2 and y1, x2 and x1. So the very first thing I did is I subtracted 1.55 to 1.30 and got 0.25, and then 0.097 to 0.598 and got negative 0.501. And then with our subtraction, error propagation, we add the absolute uncertainties. So that's how I got 0.04 and 0.002. We add those absolute uncertainties. Once we've combined the numerator and the denominator to one single value with its uncertainty, then we go into the division rule with error propagation, where we look at the fractional uncertainty of the numerator and combine it, always combine it, regardless of the negative value. In the denominator, we always combine it with the fractional uncertainty of the denominator. And we get a value here of approximately 0.16, which translates to 16% if we wanted to know the percent uncertainty. So this is actually a rather high percent uncertainty. Anything above 10 is considered a high uncertainty. But from here, we take our uncertainty to the true value that we calculated from up above, and we get an absolute uncertainty of 0.08. And this is the absolute uncertainty of the gradient. So we would say that our gradient so when we're looking for values from the gradient, when we're talking about a conclusion here, we would say that our gradient, whatever it may represent, is approximately negative 0.499 plus or minus 0.08. And that is one way that you can determine the uncertainty in your gradient. This is utilizing more of a arithmetic approach you're using the propagation rules with our gradient equation. So there will be another approach to this in the next video, but this is the way to determine the uncertainty in a gradient utilizing our uncertainty propagation